Hi, my name is Daryl, and this is another Fit Tip of the Day. Today I'd like to talk about appetite control. There are two primary factors that control appetite: chemicals that turn on the hunger receptors and chemicals that turn off the feeding cycle. The brain center that is responsible for turning on and off the feeding cycle is the paraventricular nucleus of the hypothalamus. The hypothalamus is a small gland that resides above the roof of the mouth. The paraventricular nucleus triggers the release of chemicals that assist in the feeding system of the body. The players involved in the complexity of the feeding cycle are Galanin, Norepinephrine, Neuropeptide Y, Cortisol, and the hunger hormones Ghrelin and Leptin. Here are the players in more detail. Galanin is a neuropeptide that loves fat. It is involved in the modulation and inhibits the action potentials in the neurons, also helps with the waking and sleeping cycle, helps with cognition, feeding, regulation of mood, and blood pressure. It is believed that there could be a link between Galanin production and obesity, but more research needs to be done to confirm this belief. Norepinephrine is a catecholamine that has multiple roles in the regulatory processes of the neuroendocrine system. It acts upon the adrenergic receptors of the hypothalamus and is directly involved in the appetite cycle. Neuropeptide Y acts as a neurotransmitter. It's comprised of 36 amino acids that influence the brain and autonomic nervous system. It plays many roles in the regulatory processes of the body, which include increasing food intake and storage of energy as fat, reducing anxiety and stress. It's a pain reducer, helps regulate the circadian rhythms, controls blood pressure, and is involved in controlling seizures. Cortisol, commonly known as hydrocortisone, is a steroid hormone that is secreted by the adrenal cortex. It is often termed as the stress hormone because it is released during the sympathetic nervous system response. Cortisol is a blood sugar regulator. It increases blood sugar when blood glucocorticoids levels drop due to an increased sympathetic reaction. Cortisol increases blood sugar through a process known as gluconeogenesis. Gluconeogenesis is the formation of glucose molecules by the enzymatic reactions of amino acids, glycerol, lactate, and/or propionate within the liver. Cortisol also suppresses the immune system. Cortisol has been considered to be a major factor in the role of fat storage. By reducing stress, cortisol levels can remain low, allowing for better fat metabolism. Ghrelin is a hunger hormone that stimulates hunger. It is made up of 28 amino acids, predominantly found in the lining of the stomach and the pancreas. In order for the human body to survive, it needs to have an automatic alarm clock to wake up the feeding process. Ghrelin is that alarm clock. It helps to stimulate hunger by activating the enzymatic and hormone secretions to divert the attention of the brain to begin recalling the need to eat. This is a very important hormone in regulating food intake. It increases before eating and then reduces when the stomach and digestive systems are filled with an adequate amount of food. As long as the feeding cycle is in balance, ghrelin levels remain balanced. However, if you skip meals or don't eat when the stimulatory effect of the eating cycle begins, ghrelin is released and will remain high in your blood system until the digestive system is satisfied with enough food. If there is no food, then the stress system kicks in, and this causes cortisol to get involved and also gets into the system, forcing sugar metabolism, and it begins to inhibit fat metabolism. Leptin is another hunger hormone that is responsible for satiety, turning off the feeding cycle. Leptin cancels out the stimulant effect of neuropeptide Y, turning off the feeding cycle. When leptin levels are low due to an imbalance, the receptors that activate the stimulatory chemicals continue to remain on, allowing a person to eat large amounts of food without a shutoff sequence. There is a direct link to low levels of leptin and obesity. All the chemical compounds that I have mentioned all work together to turn off and on the feeding cycle. When the natural process of the feeding cycle is compromised, then the chemicals are out of balance and cause excessive weight gain or fat gain. In the next video blog, I will be discussing how these chemicals play in the role of fat metabolism. If you have any questions regarding today's video blog, please email me. You can find my email on my website at www.darylconant.com. Thank you for watching, and I will see you next time. Take care.